So what I've got here is 1.36 grams of barium chloride, the dihydrate, I assume. And what I'm going to do is just add a little water to this. I want to try to keep the volume as minimal as possible. Alright, now that our barium chloride has dissolved, what I'm going to do is add this solution of uranyl sulfate that I made before. Okay. And that precipitates out the sulfate as barium sulfate, leaving us with uranyl chloride in solution. There we go. Let that stir up real well. Alright, what we're going to do now is I'm going to take this mixture here, pour it into a couple of tubes, and then I'm going to centrifuge it in order to remove the barium sulfate. We could filter it, but barium sulfate is very insoluble, and so because of that, it ends up making very, very small crystals that can go through even cotton plugs in a funnel. So it's very difficult to actually filter it and remove all of it. So we're not even going to fuck with that. We're just going to centrifuge it and make our lives easier. Okay, so this is done centrifuging now. Look at that. Very nice. Love the centrifuge, man. Makes life so much easier. Okay. Put that in there. Actually, there's our solution of uranyl chloride. Pretty cool, huh? Not quite as fluorescent as the chloride was. Don't you get that shit in my shit. Fucking rain. Alright, so what I'm going to do now is I am going to go and prepare a solution of cesium chloride that is 2 molar equivalents for the amount of uranyl sulfate that we had. Yes, I know there's a little bit in the bottom of this. No, we're not going to mess with it. It's just doesn't really matter. It's not very much, I mean, on the order of milligrams. So, I'm not stressing over that. Alright, so here we've got 0.93 grams of cesium chloride that was donated to the channel by Backyard Science 2000. Much thanks, my dude. I really appreciate that, man. Alright, so what we're going to do now is dissolve this in a small amount of water. Alright, now we are going to combine these two in the evaporating dish, and we are just going to let this evaporate down. Okay, there's our uranyl chloride, here's our cesium chloride. Let's give everything a little bit of a rinse. There we go. There's all of that. Give it all a stir. And there we go. Is that even showing up? Well, okay, yeah, now you can see it. I mean, there's not much to see. It's just a pale yellow clear solution. So now we're just going to let this evaporate down, and we should get our cesium uranyl chloride. Okay, everyone, so here we've got the cesium uranyl chloride. It is starting to crystallize. You can see we've got some nice crystals of it there floating on the surface. The camera does not even begin to do it justice. In the camera, it looks very pale. Maybe if I zoom out here, it just really doesn't get just how brightly and intensely colored it is. It is a very intense yellow, and the crystallized stuff has almost a greenish tinge to it. Look at that. That is fucking beautiful. So I'm going for a pretty decent excess of potassium chloride. I don't want to go too far overboard because I'd really like for it all to actually melt. I guess what I'm going to do to try to make this all work is, I know what I'm going to do. Alright, go ahead and add some potassium nitrate to this potassium chloride. Potassium nitrate may act like a flux too to help melt the potassium chloride. Which, I mean, potassium chloride isn't super high melting. It's 770 C, if I remember right. Okay, I see, I'm just mixing it up. Alright, now for an undetermined mass of uranium trioxide. We're just going to go for a little. This should be insoluble in water, so there we go. Got some dust in there, got some chunks, got a nice mix. Oh, do I want to add more? What do you guys think? Yeah, I can recycle it, right? Fuck it. Let's add some more in there. That is the wonderful thing about uranium. It is so very recyclable. Alright, time to mix this up. Now for a washing of the hands. Okay, so here is the new super heavy duty windbreak. Since the wind blows around here all the fucking time. About the only time it doesn't is like late at night. So we're going to put that there. And put that there. And, well, I guess it helps if I light it first, huh? That might be helpful. Yeah, it usually helps to light shit before you actually start assembling things. Let's see, I do not want you. Okay, let's move that bad boy under here. Alright. It even comes with a lid. Check that shit out. Pretty cool, right? So I'm gonna let this heat now for a while. I don't know. We'll let it go for half an hour, I guess. That seems a good, reasonable time. I have no idea what kind of a time frame it takes or how long to do it in. I can't imagine it would take too terribly long, though. So, I don't know. Might be better not to let it go for too long, or we might start getting the product over-oxidizing. Which I think was a problem when I did this using just plain sodium chloride, because my orange sodium uranate crystals were covered with some green shit. Or greenish shit, which I think was uranic oxide. Okay. Will this actually work? Well, I'll be damned. Redneck really is the mother of invention. Alright, let's take a look at this sumbitch. Let's see what we got. Ooh, that is a nice cherry red. Look at that. Oh, wow. Okay. I think we're good. Alright, everyone. So, here is the product of that reaction. You can see we've got our molten potassium chloride in the center, as we suspected, and this orange solid that looks very much like the uranium trioxide that I started with. Well, I'll try to do now is dissolve the melt and see what I get. As the salt is dissolving, we're getting this bright orange compound. And I do not think it's the uranium trioxide we started with. For one thing, all the big chunks that were in there aren't in our product. Okay, everybody, here are our final products. We have the Cesium Uranyl Chloride and the potassium uranate. They look beautiful under the scope, as much as I can see, so I think both of these were successful, which now we have a much better way of making alkali uranates than we had before. So that's pretty goddamn awesome. So special thanks to the uranium dude who came up with the idea of using nitrate. Although the idea to mix it with the chloride, that was all mine, although that's hardly some great intellectual leap there. So anyway, if y'all enjoyed this video, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe, comment, share the video, and until the next one, y'all, I will see you later. God damn it, that's so fucking cool.